Hi, I'm Erin Benavides, the resource teacher at Silver River Museum. Have you ever wondered about your drinking water? Like, what's in it? Where did it come from? Let's explore these ideas today. First, let's figure out where this water came from. Take a minute and think about the water in this cup. How far back could you trace it? Where do you think this started? We're here at the Florida and Aquifer exhibit in the museum to think about where that glass of water came from. So let's follow the source backwards. In this exhibit, you can see where the houses would be. And if you're in your house, you turn on the tap and water amazingly comes out. And that's because you're connected to a well, whether it's a private well or a public well. And they're like big drinking straws. They go down into the ground where the aquifer is located. And all of the aquifer is surrounded by limestone. So how did this aquifer get filled up with water to begin with? Well, it's a constant process. You see, the ground above is like a sponge. So when it rains, the water percolates or moves through the sponge and recharges the aquifer. So really, that glass of water that we had earlier came from the rain. It just took a long journey to get from the rain to the aquifer, to our well, and into our home. All right, so we're back in the classroom, and what we know is this tap water was once rainwater. This is actual rainwater that I've collected from outside. And the question is, are they the same? If we look at them, they certainly look the same. But sometimes scientists can use some other methods to learn a little bit more. And so that's what we're going to do today. I have some special paper. It's called pH test paper, and it's going to allow us to measure a chemical property called pH about this water. All I have to do is dip the strip in the water, and then I'll give it a few minutes, and it will change colors depending on the pH of the water. There's a little chart inside the pH test strip booklet, and we'll compare the color of the strip with the chart, and it will tell us the pH of each water. If I look at the tap water and hold it up and compare colors, it's telling me that the pH of the tap water is 7. And 7 is what we call neutral. And that's what we'd expect for our drinking water. Now here's the rainwater. Its pH is actually showing it's a 6. And a 6 means it's very slightly acidic or an acid. Think lemonade. That's an acid. So our tap water and our rainwater are not the same. What makes them different? There's all sorts of substances that this rainwater is going to come in contact with along its path before it comes through our sink as tap water. Sometimes these substances can mix so uniformly that they become a solution and they can change the chemical properties of the water. So let's think about what along that path may have interacted with the rainwater to change its pH. I have 2 different items for us to test today. We know when this rain comes down, it comes in contact with sand. In fact, one of our major recharge locations in Silver Springs State Park is known as the Sand Hill, which is covered in sand. So do you think the sand could be affecting the pH of the water? And then if we follow the water a little further along its path, once it's gone underground, it comes into contact with this. This is that lime rock forming the aquifer. Is it possible that the lime rock has an effect? We're going to do a very simple test today to find out. So I could put this lime rock straight in the rainwater and see if it affects it, but this rock is really big, and it would take a long time for us to notice anything. So there's some ways that we can speed up solutions. The sand particles are very fine. If we could get this lime rock to be about the same size, then the reaction time would be similar for the sand and the lime rock. So crushing this is kind of a tough job, but there's an alternative. This is a piece of chalk. Chalk is made of the same ingredients as lime rock. Chalk is really easy to crush up. In fact, in my little petri dish, I just used the back of my spoon and I have some crushed up. So let's set up our experiment. I've got my 2 mixing containers, and in both of these, one's labeled sand and one is labeled lime rock. I'm going to put some rainwater. We will mix in some sand and some lime rock to both of them. Something that could speed up this mixing evenly and becoming a solution is stirring it. So I'll go ahead and stir them both. We're going to go ahead and pour this through a filter, and then we'll test the water that comes through the filter. So I'm going to get 2 new pH strips, and first I will dip it in the sand and rainwater, and then I will dip it in our lime rock and rainwater. All right, so let's take a look at the sand. And what you'll notice, if this is the tap water and this is the sand and the rainwater, that did not make the water neutral. In fact, the water still looks very much like the pH strip from the rain. That rainwater's the same. So the sand did not change the pH of the water. Now let's take a look at the pH of the rainwater and the lime rock. So here's our test strip, and I'm going to compare it to our control group here of the tap water. And they look very similar. And in fact, if I use my little guide again, the pH of this water is 7, just like the tap water. So what we've shown here is that when water reaches the lime rock under Florida, it reacts, it combines, and it makes a solution. And what we end up with is neutral tap water because of the solution between the very slightly acidic rainwater and the lime rock. I'm along the water's edge of the beautiful Silver River, and believe it or not, this water from the river came from the same place as your drinking water. It came from the aquifer. You see, this river is spring-fed. A spring is an opening in the aquifer, and over 500 million gallons of water a day fill this river. So, would you drink this water like you drink the water from your tap? You know, scientists always wonder about the water quality of this river, and so they're frequently testing it. Do you think there are any other substances that dissolve in the water along its path to this river? Well, if you said yes, you'd be right. One of the main pollutants that we find in this river is known as nitrates. Nitrates come from a couple different places. They can come from fertilizers, and they can also come from human and animal waste. Too many nitrates can cause a body of water to become unhealthy. Take a look at some of these images showing the river years ago and today. You will notice a stark difference, and that difference is because of the increased level of nitrates in this water. How do you think the nitrates got here? Think about how we traced the water back when we were trying to figure out where our tap water came from. See if you can determine how the nitrates would have gotten in this water. As we have more and more people moving to Florida every year, we're going to have more and more nitrates found in this river unless we find a way to prevent the nitrates from entering our waterways. Thank you for joining me for this lesson. I'll be hosting some live Zoom sessions, so be sure to check out the calendar I've posted. And if you miss the live Zoom sessions, we'll record them so that you can watch the recorded Zoom. The first one will be all about how to take polluted water and filter out some of the pollutants. It's a design challenge that you can participate at school or at home. So I hope you'll join me. See you soon.